Welcome to this lesson 8, which encompasses question number 1 to question number 13 of ESSLCE or University Entrance Examinations of the year 2011 Ethiopian calendar. Question number 1. If f of x is equal to ax cubed plus b over x plus 5 has a local minimum at 2, -3, what is the values of a and b? We are asked two unknowns, that's a and b. To find the values of these two unknowns, we need to have two equations. So, from where can we generate these two equations? Let's focus on givens. That's the local minimum 2, -3 and the function f of x. For a given function, a local minimum is attained at a point where f derivative of x is equal to 0 or f derivative of x doesn't exist. So let's solve for f derivative of x. F derivative of x is equal to the derivative of ax cubed, that is a constant a, times the derivative of x cubed is, let's bring 3 to the front, 3 times x to the power of 3 minus 1, plus the derivative of b over x means b times x to the power of -1 derivative, plus the derivative of 5 is 0, which is equal to 3 times a is 3a, times x to the power of 3 minus 1 is x squared, plus b times the derivative of x to the power of -1 is -1 times x to the power of -1 minus 1, which is equal to 3a squared, plus b times -1 is minus b, times x to the power of -1 minus 1 is x to the power of -2, which is equal to 3a squared minus b times x to the power of -2 means b over x. As we discussed, local minimum is achieved at either f derivative of x is equal to 0 or at f derivative of x doesn't exist. F derivative of x doesn't exist at x is equal to 0 because x squared is at the denominator of the expression b over x squared. But f of x is undefined at x is equal to 0 because x is at the denominator of b over x. Thus, the minimum is achieved at f derivative of x is equal to 0. F derivative of x is equal to 0, that is 3ax squared minus b over x squared is equal to 0. If the local minimum is at 2, -3, then f derivative of 2 is a point where a local minimum is achieved. F derivative of 2 is equal to 0. This implies 3 times 2 squared minus b over 2 squared is equal to 0. This implies 2 squared is 4, 4 times 3 is 12 times a. Taking minus b over 2 squared to the right of the equality, we will find b over 2 squared is 4. This implies, multiply both sides by 4, we will find b over 4 times 4 is b, which is equal to 4 times 12 is 48a. This is one of the equations we are looking for. From the order pair 2, -3, we can figure out that f of 2 is equal to -3. That is a times 2 cubed plus b over 2 plus 5 is equal to -3. This implies a times 2 cubed is 8 plus b over 2. Taking -5 to the other side of the equality, we will find -3 minus 5. This implies 8a plus b over 2 is equal to -3 minus 5 is -8. Multiply both sides by 2. We will find 2 times 8a is 16a plus b over 2 times 2 is b, which is equal to -8 times 2, that's -16. We already discovered that b is equal to 48a, so plugging 48a to b, we will find 16a plus 48a is equal to -16. 16a plus 48a gives 64a is equal to -60. Dividing both sides by 64, we will find a is equal to -16 divided by 64, which is equal to -1 over 4. If a is equal to -1 over 4, then b is equal to 48 times -1 over 4. By 4, 1. By 4, 12. 12 times -1 is -12. The values of a and b are -1 over 4 and -12 respectively. Thus, choice A is the correct answer. Question number 2. What is the simplified form of a to the power of -1 times b to the power of -1 divided by a to the power of -3 minus b to the power of -3? A to the power of -1 times b to the power of -1 divided by a to the power of -3 minus b to the power of -3 is equal to a to the power of -1 is 1 over a times b to the power of -1 is 1 over b divided by a to the power of -3 is 1 over a cubed minus b the power of negative 3 is 1 over b cube. This is equal to 1 times 1 is 1 divided by a times b is ab, the whole over the LCM of a cube and b cube is a cube b cube. A cube b cube divided by a cube is b cube. B cube times 1 is b cube minus a cube b cube divided by b cube is a cube. A cube times 1 is a cube, which is equal to the fraction at the numerator divided by the fraction at the denominator gives the numerator times the reciprocal of the denominator, that is 1 over ab times a cube times b cube divided by b cube minus a cube, which is equal to a cross out 1a at the numerator, then we left with a square. Again b cross out 1b at the numerator, left with b square divided by b cube minus a cube. So the correct answer is choice C. Question number 3. Consider the following system of equations, that is x minus 2y plus z is equal to 1, negative x plus y plus z is equal to 3, 3x minus 5y plus z is equal to k. How much must be the value of k so that the system has a solution? In the system, we are given with 3 equations and 4 unknowns, that is x, y, z and k. Whenever the number of unknowns are greater than the number of equations, like the case in this system, it's difficult to determine the values of the unknown by solving simultaneously or by substituting one variable by another. The method recommended for such system of equations is row-reduced echelon form. To work on this method, set the matrix to the form, that's the coefficient matrix at the left. The coefficient of variables in equation 1 has to be set in row 1, that's 1, negative 2, 1. The coefficient of variables in equation 2 to row 2, that's negative 1, 1, 2. And the coefficient of variables in equation 3 at row 3, that's 3, negative 5, 1. Set the values to the right of each equation to the right of the corresponding row. 1, the value to the right of equation 1 at row 1. 3, the value to the right of equation 2 at row 2. And k, the value to the right of equation 3 at row 3. Then draw this vertical line to separate the values of the coefficient from those of the right side of equality. To move on row-reduced echelon method, first convert first element of row 1 to 1. It's by default 1. Second, convert the values under 1 in column 1. That's negative 1 from second row and 3 from third row to 0. Because the leading entry of row 1 is the only non-zero element in this column. For such conversion, focus on entry elements of row 1. That is, to convert negative 1 to 0, we have to add positive 1. Thus, the row operation needed for this step is row 2 plus row 1 and then put it in row 2. Row 1 will be the same. Row 2 elements, 1 plus negative 1 is 0. Negative 2 plus 1 is negative 1. 1 plus 1 is 2. 1 plus 3 is 4. The value to be converted to 0 in row 3 is 3. To convert 3 to 0, we have to add negative 3. Thus, the row operation needed at this stage is negative 3 times row 1 plus row 3, and then put it in row 3. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times negative 2 is positive 6. Positive 6 plus negative 5 is 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. Negative 3 times 1 is negative 3 plus k is minus 3 plus k. The next step, convert the leading entry of row 2, that's negative 1 to 1. Simply multiply row 2 by negative 1 and then put it in row 2. Row 1 and row 3 will be the same. Negative 1 times 0 is 0. Negative 1 times negative 1 is positive 1. Negative 1 times positive 2 is negative 2. Negative 1 times positive 4 is negative 4. Convert elements below and above the leading entry of row 2. That's negative 2 from row 1 and 1 from row 3 to 0. Because this 1 is the only non-zero element in this column. So for converting negative 2 to 0, we have to add positive 2. So the row operation needed at this stage is 2 times row 2 plus row 1 and then put it in row 1. 2 times 0 is 0, 0 plus 1 is 1. 2 times 1 is 2, 2 plus negative 2 is 0. 2 times negative 2 is negative 4, negative 4 plus 1 is negative 3. 2 times negative 4 is negative 8, negative 8 plus 1 is negative 7. Row 2 will be the same. The element to be converted to 0 in row 3 is 1. So to convert 1 to 0, we have to subtract 1 from 1, or we have to add negative 1 to positive 1. So the row operation needed at this stage is negative 1 times row 2 plus row 3, and then put it in row 3. Negative 1 times 0 is 0, 0 plus 0 is 0. Negative 1 times positive 1 is negative 1, negative 1 plus 1 is 0. Negative 1 times negative 2 is positive 2, positive 2 plus negative 2 is 0. Negative 1 times negative 4 is positive 4, positive 4 plus negative 3 plus k is 1 plus k. Now we reach to the step where we can decide whether the system has a unique solution, no solution, or infinitely many solutions. Possible solutions of the system. If the last row has a form 0, 0, C and K, then the system has a unique solution. The second alternative, if the last row has a form 000, K, then the system has no solution. If the last row has a form 400, then the system has infinitely many solutions. But in our equation, it's mentioned that the system has solutions. So our equation has to take the form of this final row. It has to take the form of alternative 3. So 1 plus k should be is equal to 0. Taking plus 1 to the right of equality, we will find k is equal to negative 1. Hence, choice A is the right alternative. Question number 4. If the determinant of a 3 by 3 matrix with elements of first column negative 1, 3, 2, elements of second column 1, 2, 4, and elements of third column 2x, 1 is equal to a determinant of another 3 by 3 matrix with elements of first column negative x, 2, 1, and elements of second column 3, 2, negative 1, and elements of third column 2, 3, negative 2. Then what is the value of x? The determinant of the least matrix is equal to negative 1 times, we'll cross out row 1 and column 1, we left with 2 times 1 minus 4 times x, minus 1 times, cross out row 1 and column 2, we left with 3 times 1 minus 2 times x, plus 2 times, in this case cross out row 1 and column 3, then we left with 3 times 4 minus 2 times 2, which is equal to the determinant of the right hand side matrix, that's negative x times, cross out row 1, column 1, we left with 2 times negative 2 minus 3 times negative 1 minus 3 times, cross out row 2 and column 1, we left with 2 times negative 2 minus 1 times 3 plus 2 times, cross out column 3 and row 1 in this case, then we left with 2 times negative 1 minus 2 times 1. This implies negative 1 times 2 times 1 is 2 minus 4 times x is 4x minus 1 times 3 times 1 is 3 minus 2 times x is 2x plus 2 times 3 times 4 is 12 minus 2 times 2 is 4, which is equal to negative x times 2 times negative 2 is negative 4 minus 3 times negative 1 is negative 3 minus 3 times 2 times negative 2 is negative 4 minus 1 times 3 is 3 plus 2 times negative 1 is negative 2 minus 1 times 2 is 2. This implies negative 1 times 2 is negative 2, negative 1 times negative 4x is plus 4x, negative 1 times 3 is negative 3, negative 1 times negative 2x is positive 2x, plus 2 times 12 minus 4 is 8, which is equal to negative x times negative 4 minus negative 3 means plus 3 minus 3 times negative 4 minus 3 is negative 7 plus 2 times negative 2 minus 2 is negative 4. This implies 4x plus 2x is 6x minus 2 minus 3 means minus 5 plus 2 times 8 is 16, which is equal to negative 6 times negative 4 plus 3 is negative 1 plus negative 3 times negative 7 is positive 21 plus 2 times negative 4 is negative 8. This is equal to 6x. 16 minus 5 is 11 is equal to negative 6 times negative 1 is positive x plus 21 minus 8 is 13. This implies collecting like terms, that is 6x minus x is equal to 13 minus 11. This implies 6x minus x is 5x, which is equal to 13 minus 11 is 2. Dividing both sides by 5, we will find x is equal to 2 over 5. Thus, choice D is the correct answer. Question number 5. What is the value of the left hand side limit? That's limit of sin x over x squared times the square root of 4x cubed plus 9x squared as x approaches to 0 from the left. Limit of sin x over x squared times the square root of 4x cubed plus 9x squared as x approaches to 0 from the left can be rewritten as limit of sin x over x squared means x times square root of 4x cubed plus 9x squared as x approaches to 0 from the left is equal to limit of sin x over x times the square root of 4x cubed plus 9x squared divided by x as x approaches to 0 from the left, because multiplication is commutative. The product rule specifies that this limit can be expressed as limit of sin x over x as x approaches to 0 from the left times limit of the square root of 4x cubed plus 9x squared divided by x means square root of x squared as x approaches to 0 from the left, which is equal to sin 0 is 0 divided by 0, which is undefined. In such case, it is recommended to take the limit of the derivative of both the numerator and the denominator. Thus, limit of sin x over x becomes limit of the derivative of sin x is cos x divided by the derivative of x is 1 times limit of the square root of 4x cubed divided by x squared is 4x plus 9x squared divided by x squared is 9. So at this stage, it's possible to substitute 0 to x because both functions are defined at x is equal to 0. Thus, cosine 0 divided by 1 times the square root of 4 times 0 plus 9, which is equal to cos 0 is 1, 1 divided by 1 is 1 times 4 times 0 is 0, 0 plus 9 is square root of 9. 1 times square root of 9 is square root of 9. Square root of 9 is equal to 3. Choice A is the correct answer. Question number 6. Which one of the following is equal to f of x is equal to square root of x plus 4 the whole square for every x elements of real number? By definition, square root of x squared is equal to absolute value of x. In other words, square root of x squared is equal to square root of x plus 0 the whole square, which is equal to absolute value of x plus 0. Absolute value of x plus 0 is simply equal to absolute value of x. If we substitute 0 by any constant c, then square root of x plus c the whole square is equal to absolute value of x plus c. Thus, square root of x plus 4 the whole square is equal to absolute value of x plus 4. Therefore, choice B is the right alternative. Question number 7. Let z be a complex number and w is equal to 3 plus 4i. If z squared plus 1 divided by z plus I is equal to the magnitude of w times z minus 1 over I times the conjugate of w, then what is the value of z? Let's simplify the left and the right hand expression separately. To solve for z squared plus 1 divided by z plus 1, let's find the relationship between plus 1 and I. By definition, I is equal to square root of negative 1. Taking square of both sides, we will find I square is equal to square root of negative 1 square. This implies I square is equal to the square of negative 1 square is simply negative 1. Multiplying both sides by negative 1, we will find negative 1 times I square is negative I square, which is equal to negative 1 times negative 1 is positive 1. Thus, the expression z square plus 1 divided by z plus I is equal to z square plus 1 means minus I square divided by z plus 1. The square of the difference between z and I can be expressed as z plus I times z minus I divided by z plus I. Z plus I cross out by z plus I, we left with z minus I. To simplify the right hand side expression, that's the magnitude of w times z minus 1 over I times the conjugate of w is equal to magnitude of w is the square root of 3 square plus 4 square times z minus 1 over I times, to find the conjugate of w, simply take the opposite of the sign in front of the imaginary part. The imaginary part is 4i, the sign in front of 4i is positive, so the conjugate of w is 3 minus 4i, which is equal to the square root of 3 square is 9 plus 4 square is 16 times z minus 1 over I times 3 minus 4i. To remove I from the denominator, let's multiply both the numerator and the denominator by I, which is equal to 9 plus 16 is 25 times z minus 1 times I is I divided by I times I is I square times 3 minus 4i, which is equal to square root of 25 is 5z minus I divided by I square is negative 1 times 3 minus 4i, which is equal to 5z. Negative divided by negative becomes positive I times 3 minus 4i, which is equal to 5z plus I times 3 is 3i minus I times 4i is 4i square, which is equal to 5z plus 3i. I square is negative 1, negative 1 times negative 4 is plus 4. Finally, let's equate the right and the left hand side expressions. That's z square plus 1 divided by z plus I is simply z minus I, which is equal to magnitude of w times z minus 1 over I times the conjugate of w is simplified as 5z plus 3i plus 4. Let's collect like terms, that is z minus 5z is equal to, let's bring the real part to the front, that is 4 plus 3i. Taking negative 1 to the other side of the equality, we will find positive I. This implies z minus 5z is negative 4z is equal to 4 plus 3i plus I is 4i. Dividing both sides by negative 4, we will find negative 4z divided by negative 4 is z, which is equal to 4 divided by negative 4, that's negative 1. 4i divided by negative 4 minus I. Hence, choice A is the correct answer. Question number 8. If a circle passing through a point negative 1, 0 and touches y-axis at 0, 2, then what is the equation of a circle? For visualizing the circle clearly, let's draw it. This is the xy plane. Negative 1, 0 is the order pair located 1 unit to the left of the origin. 0, 2 is the order pair located 2 units above the origin. The circle looks like this. It touches 0, 2 and passes through negative 1, 0. Let h, k is the center of a circle. Thus, the standard form of equation of a circle becomes x minus h the whole square plus y minus k the whole square is equal to the radius r square. Here we have three unknowns, that is h, k and r. To solve these three unknowns, we need to have three equations. So let's proceed to generate these three equations. The slope of a horizontal line passing through the center h, k and the point of tangency 0, 2 is 0 because it is perpendicular to the y-axis, which is tangent to the circle at 0, 2. So the slope of the line is k minus 2 divided by h minus 0 is equal to 0. 0 means 0 over 1. Then multiplying crisscross, we will find k minus 2 times 1 is k minus 2 is equal to h minus 0 times 0 is 0. Taking negative to the other side of equality, we will find k is equal to 2. The length of a line from the center to each of negative 1, 0 and 0, 2 are equal because they both represent the radius of a circle. Thus, h minus negative 1 the whole square plus 2 minus 0 the whole square is equal to h minus 0 the whole square plus 2 minus 2 the whole square. h minus negative 1 means h plus 1 square plus 2 minus 0 is 2, 2 square is 4 is equal to h minus 0 is h, that's h square, plus 2 minus 2 is 0, 0 square is 0. H plus 1 the whole square is the square of the first term, that's h square, plus 2 times h times 1, that's 2h, plus the square of the second term, that's 1 square, which gives 1, plus 4 is equal to h square. H square cancelled by h square, then we left with 2h plus 1 plus 4 means plus 5, which is equal to 0. Taking positive 5 to the right of equality sign and then dividing by 2, we'll find h is equal to negative 5 over 2. Thus, the center of a circle is negative 5 over 2, 2. Now, we can solve the radius because we determine the initial points, that's the center, and the final points of R, that is either negative 1, 0 or 0, 2. So let's calculate the radius as a distance from negative 5 over 2, 2 and 0, 2. So radius is equal to the square root of negative 5 over 2 minus 0 the whole square plus 2 minus 2 the whole square, which is equal to negative 5 over 2 minus 0 is negative 5 over 2. Negative 5 over 2 square is 25 over 4 plus 2 minus 2 is 0. 0 plus the number itself, that's 25 over 4. Square root of 25 over 4 is 5 over 2. At this stage, we determined all the three unknowns. Hence, the equation of a circle is x minus negative 5 over 2 the whole square plus y minus 2 the whole square is equal to 5 over 2 square. X minus negative 5 over 2 means x plus 5 over 2 square plus y minus 2 square is equal to 5 square is 25 divided by 2 square is 4. X plus 5 over 2 square, that's the square of the first term, is x square plus 2 times x times 5 over 2, that is 5x, plus the square of the second term, that is 5 over 2 square, which gives 25 over 4, plus y minus 2 the whole square, that's the square of the first term, y square, minus 2 times the two terms, that's 4y, plus the square of the second term, that's 2 square, which gives 4, is equal to 25 over 4. Let's rearrange this equation, that's x square plus y square plus 5x minus 4y plus 25 over 4 plus 4 minus 25 over 4 is equal to 0. 25 over 4 minus 25 over 4 is 0. Thus, we left is x square plus y square plus 5x minus 4y plus 4 is equal to 0. So, choice B is the correct answer. Question number 9. What is the value of integral of ln x over x square dx? X range from 1 up to 2. Integral of ln x over x square dx, x ranging from 1 up to 2, can be rewritten as ln x times 1 over x square dx, x ranging from 1 up to 2. So, let's use integration by part to solve this equation. Let u is equal to ln x, then the derivative of u is equal to, the derivative of ln x is 1 over x times dx. Again, let dv is equal to the remaining expression, that's 1 over x squared dx. Then integral of dv is equal to integral of 1 over x squared means x to the power of negative 2 dx. Integral of dv is v, which is equal to integral of x to the power of negative 2 is x to the power of negative 2 plus 1 divided by negative 2 plus 1, which is equal to x to the power of negative 2 plus 1 is negative 1 divided by negative 2 plus 1 is again negative 1, which is equal to x to the power of negative 1 divided by negative 1 means minus 1 over x. So let's rewrite the equation. Integral of ln x times 1 over x squared dx is equal to integral of, we substitute ln x by u times, we substitute 1 over x squared dx by dv. Integration by part specifies that integral of u dv is equal to uv minus integral of v du, which is equal to u means ln x times v means negative 1 over x minus integral of v means negative 1 over x times du means 1 over x dx, which is equal to negative 1 times ln x is minus ln x divided by x. Negative 1 is a constant, so we can bring it to the front. That's negative 1 times negative 1 becomes plus integral of 1 times 1 is 1 divided by x times x is x squared dx, x ranging from 1 up to 2, which is equal to minus ln x divided by x. Integral of 1 over x squared dx is already determined as minus 1 over x ranging from 1 up to 2. So substituting 2 and 1 in place of x, we will find minus ln 2 divided by 2 minus 1 over 2 minus ln 1 divided by 1 minus 1 over 1, which is equal to minus ln 2 divided by 2 minus 1 over 2. This negative outside the bracket, multiply all the stuffs inside the bracket, thus we will find negative 1 times ln 1 is ln 1. 1 over 1 means 1. Negative 1 times 1 is positive 1, which is equal to ln 1 is 0. Thus we left with minus ln 2 over 2. Negative 1 over 2 plus 1 is plus 1 over 2. Therefore, choice D is the right alternative. Question number 10. Every day a person saves 5 cents more than the amount he saved on the previous day. His target is to save a total of 3,225 cents by the end of 30 days. How much must be the starting saving to meet the target? The givens, that's a total of the 30 days saving, that is S sub n is equal to 3,225 cents. The number of days of which the saving will continue, that's n is equal to 30 days. The third given is the difference between the successive days savings, that is d is equal to 5. The sum of S sub n of n terms of an arithmetic sequence with the first term a sub 1 and the common difference d is given by the formula S sub n is equal to n over 2 times 2a1 plus n minus 1d. For the 30 days saving, we will write the formula as S30 is equal to 30 over 2 times 2a sub 1 plus 30 minus 1 times 5. This implies S30 is given as 3,225 cents, which is equal to 30 over 2 is 15 times 2a1 plus 30 minus 1 is 29 times 5 cents. Divide both sides by 15, we will find 3,225 divided by 15 is equal to 215, which is equal to 2a1 plus 29 times 5 is 145. Rearranging the equation, we will get a1 is equal to 215 cents minus 145 cents divided by 2. 215 minus 145 gives 70 divided by 2. 70 divided by 2 is 35. Thus, choice D is the correct answer. Question number 11. If there are 2 children in a family, what is the probability that at least one girl in a family? The possible outcomes, both of them can be boys. The first one can be boy and the second girl. The first one can be girl and the second boy. The last, both of them can be girls. So the probability of at least one girl is equal to probability of one girl plus probability of 2 girls. The probability of one girl is 2 over 4 plus probability of one girl is 1 over 4. 2 over 4 plus 1 over 4 is equal to 3 over 4. Therefore, the correct answer is choice B. Question number 12. If f of x is equal to integral of e to the power of negative t dt, t ranging from 0 up to x, then what is the value of f derivative of x? Integration by substitution is appropriate to solve this integral. Thus, let u is equal to negative t, then derivative of u is equal to the derivative of negative t is minus 1 dt. Multiplying both sides by negative 1, negative 1 times du is negative du is equal to negative 1 times negative dt is dt. Thus, integral of e to the power of negative t dt, t ranging from 0 up to x is equal to integral of, we substitute e to the power of negative t by e to the power of u times dt means negative du, which is equal to, negative is a constant, we can take it to the front, that's negative integral of e to the power of u times du, u ranging from 0 up to x, which is equal to, integral of e to the power of u is e to the power of u, e to the power of u times negative 1 is negative e to the power of u, u ranging from 0 up to x. We know e the power of u means e the power of negative t. Thus we will get negative e the power of negative t, t ranging from 0 up to x, which is equal to negative times e the power of negative x minus e the power of 0, which is equal to negative 1 times e the power of negative x is negative e the power of negative x. E the power of 0 is 1. Negative 1 times negative 1 is plus 1. Therefore, choice C is the correct answer. Question number 13. Which one of the following is true about a pair of lines 3x plus 9y minus 24 is equal to 0 and 4x plus 12y plus 32 is equal to 0? The choices are asking whether the two lines are perpendicular, parallel to each other, intersect each other, or they represent the same lines. To identify which alternative is right, let's write the equation in terms of y. That's 3x plus 9y minus 24 is equal to 0. Can be rewritten as taking 3x and negative 24 to the right of the equation, we will find 9y is equal to negative 3x plus 24. Dividing both sides by 9, we will find y is equal to negative 3 over 9x plus 24 over 9, which is equal to negative 3 over 9 means negative 1 over 3x plus 24 over 9 is 8 over 3. The other equation, 4x plus 12y plus 32 is equal to 0. Taking positive 32 and positive 4x to the right of equality, we will find 12y is equal to negative 4x minus 32. Dividing both sides by 12, we will find y is equal to negative 4 over 12x minus 32 over 12, which is equal to by 4, 1, by 4, 3, that's negative 1 over 3x, minus by 4, 8, by 4, 3, that's 8 over 3. Thus, the slope of the two lines are the same, that's negative 1 over 3. So they are either parallel or representing the same line. Their y-intercepts are different. That's the y-intercept of the first equation is positive 8 over 3, and the y-intercept of the second equation is negative 8 over 3. So they are representing different lines. In other words, the two lines are parallel and distinct. Therefore, choice D is the correct answer. This brings the end of this installment. As usual, subscribe, like and share this page in order to receive more lecture videos. Have a nice time.